In the video number 15 in the Foundations of the Computational Economics course, we're looking at the library Pandas, which is essentially the tool for data manipulation in Python. Pandas is the member of the scientific stack that we mentioned in the previous video, together with NumPy, SciPy, Number, and Matplotlib. So what is Pandas? Well, it is a library that provides classes for the two main classes that are used to work with data, a series class and a data frame, where series can be thought of a time series data holder, and the data frame is sort of the panel data. It provides the methods for manipulating the data, indexing, sorting, grouping, filling in missing data, and so forth. But it does not provide the modeling tools. So Pandas is used for manipulating the data, whereas other packages like scikit-learn and so forth and other are used for statistical data analysis models. So what is a data frame? You can think of data frame as a sort of a complicated matrix, or better yet, a spreadsheet, like an Excel or Google Sheets. The data is situated in cells, organized in columns and rows. Many different columns have there can be in the data frame object. Only one of them is in the series object. The columns have names, and the rows may have names, which is referred to as index, or could be just numbered. So let's create a data frame object. Well, first we have to import Pandas, and we import it as PD, which is the standard nickname for this library. And then, as you can see, we just say pd read as CSV, comma separated value. This is the file which is provided with the with lecture notes, and we get this object. This is the Pandas object, the data frame. We can read the help that comes together with it and describes the main methods and attributes of the objects. Well, let me not go into that right now. You can see that Pandas provides very useful tools for already uploading or reading the data from the disk. Well, what can we do with this data? A very useful command method is head. It allows us to print the first so many rows in the data that we have imported. And you can see that the data that we're looking at, which is called the recent grads CSV. This is the data on the labor market outcomes for the students who have recently graduated from different degrees. It has a code for the major, the rank in terms of the earnings, I believe, the total number of people, men and women, the categories of the major have some groupings, the share of women, the sample size in this particular major, employed, part-time, full-time, unemployment rate, and this is the median or the median salary. Some percentiles of the distribution, and then characteristics of the jobs. This file actually has many records, and we will see in a second how many. The data comes from this source. This is the data which was used by the 538 analytical company to talk about the how you should pick a college major. You can check out these links. Well, the data dictionary is actually here, and that's quite useful. So here's the description of all of the variables that we have. Median earnings of full-time year-round worker. That's the salary, essentially. Okay, let's just look at some methods that exist for data frames. Well, the info method describes to us the data in the columns, their names, the data type, the D type, similar to the NumPy array. How many entries do we have? We have 21 column and 173 different majors. Individual columns of the data, as I said, they are represented by the series object. And the way we create this object is by referencing the names of the variables in the data frame. And this is the same way you would work with dictionaries in Python. So the type of the data1 is series, right? Pandas core series object. What do we have in the first 5 observations? Well, if we look at major, then we have the description, textual description of the major. We can access multiple columns of the data and create a sort of a nested data frame, and this is done by providing a list of column names that we want to access. Here we have the major and the shares of women in that major, first 5 observations. Creating new variables is done in a status style, where a variable, or it can be done in a status style. And I mean by that we can write a formula for the variable that is a whole column of observations. So for example, here I want to introduce a new column called employment rate, and that's, the formula is just to take a fraction of the employed to the total number of people. And let's look at that. So I'm looking at the first observations in here, the total number of people, the number of employed, here's the employment rate. So that's possible to do with data frames. Let's take a mean. So there is a number of these aggregating functions which are available, similar to the NumPy. Here I want to look at the column corresponding to the unemployment rate we just created, and I want to calculate the mean unemployment, and that's about 6.8%. So I multiply by 100 to get percentage. Describe provides some summary statistics for the particular column. The count, the number of observations, the mean, that's what we just saw, standard deviation, some characteristics of the distribution. Simple plots are available directly from Pandas, although we still have to import matplotlib, and again, this magic command that allows it to the resulting plots be imported directly into Jupyter Notebook. So here's the plot which shows the share of women on the X. Let me reduce the scale here. The share of women, and this is the median salary. Can you see downward bias? Well, I guess yes, we can. Imagine this is a linear regression, and we want to put a line through here. So here's a short command that describes how the plot should be done. Remember, data is the data frame object, so we're using the method of the data frame object here. But we are making the plot in a very similar way as we would do in matplotlib. All right, selecting and filtering is an important topic to understand. So data frames can be sliced similar to the NumPy arrays up to the 3rd row. Now this refers to the rows. So I'm going to take 0th, 1st, 2nd, and 3rd row in the table, all the columns. Sorting values is done by invoking the standard method for sorting. Let's sort by the share of women in the descending fashion and take the top 3. So these are the majors which have the highest shares of women, and you can see this is 0.96 and 0.92 here. Early childhood education, communication disorders, medical assisting services, things like that. Another way to select rows is to use the row labels. And as I mentioned before, this is what's called an index of the data set. So we can set index to a particular variable. Right now, the index, if we go back or to any of this head, right now the index is just the integers, right? Just the numbers from 0 and up. But we can set a different index. So for example, a major code is a unique identifier for the rows. And we can set the index to this variable. And now you can see that the major code is going to be our referral, the pointer to different rows. But it's important to see to note here that we are working with the data frame, but we are not changing it in place, right? So when we say set index, we've created a new data set, and we're showing the head of this new data set. In order to keep the changes, we need to rewrite the data set in a sense. So here's the index which of the original data. But here we can rewrite the index into the data frame that we had. And so now data will have the index which corresponds to the major code. Or we could say the additional argument in place equals true to do this, to achieve the same result. With the index set, we can use the method lock to refer to the values of the index to find variables. So here's to find rows. I'm sorry. So here's a particular row corresponding to the index 2405, and that's the code of a particular major. Now we can do the same with lists of codes as well, of course. So here's two different major codes that we are looking at. Now, it's a good idea to sort indices to make access to the data faster, and that's the original idea under indices. And we achieve that with this command sort index. And then you can see that if we look at the head again, then we're starting from a particular index and they go in order. Selecting rows using a criterion is done in the following way. We can have a selection, which is a logical expression of a particular variable equal to a particular value. And as similar to the NumPy accessing of the elements, this you can think of this as being a mask. So we are looking only at those rows where this condition is satisfied, so the mask is true. And you can see that we are looking this way. We are looking at all of the majors where the major category is arts. All right. We're doing it the same, but we also want to see not only that it's arts, but that this is the major that leads to a salary of over $100,000. And there's only one such major, commercial art and graphic design. So if you want higher salary in arts, that's what you should be doing. Now, grouping and aggregating data is a needed and a powerful technique to have sort of intermediate results in looking at the data. And we do that, we do grouping by using the group by function. So data grouped by major category is going to create a new object, which is called grouped. So in this case, a new object of the type DataFrame group by object. Okay, and what is it? Let's try to see inside. Well, the type grouped is this DataFrame group by object, but if I look at grouped groups, then what I see is essentially, and this is the printout, right? This is essentially a dictionary where the keys are in the dictionary are the values of the original major category, and then the values under these keys are the lists. Well, not lists, but indices, which essentially list the indices corresponding to the rows that form that particular group. So essentially, this is a partition of our data frame into different sections according to a given criterion. what do we do with these groupings? Well, of course, we then can calculate different statistics based on these different groupings. And here's a link to a whole list of different statistics that we can calculate. So, for example, grouped mean would give us the mean of all of the variables according to the grouping, and the grouping is the major category, right? So in arts, for example, where's the median salary? The median salary is 33,000. And we saw that only one particular major leads to a salary over 100,000. We can also just look at one particular variable to calculate the aggregate statistics. And here I'm looking at that median salary by the major category, as you can see here. And here's our statistics table. It's easy to achieve multiple statistics if we want to calculate, to build some, a table of descriptive statistics in this way. So here I'm adding median and standard deviation. We can plot grouped objects. And so here, for example, I'm going to have a bar plot. This is a grouped median. We calculate the mean, and then we want to plot these means using bars with a particular figure size. And then on the axis, on the x-axis, we get the different major categories. Now, all of this data manipulation is working with a single table, but let's look whether we can combine different tables together. I'm going to use 3 data frames which are just artificially created. And here's the way how to create data frames artificially. So we will have a subject ID, first name, and last name, 3 variables, and I just list the values of these variables. And the same thing here. So imagine that the subject ID is the class that different people are taking, and then the first name and the last name is the identifier of a particular person. And then, I don't know, there are some tests which correspond to the subjects that people are taking. So these are the 3 data frames that we want to work with. Let's see how we can combine them. Well, first let's first create the data frame, data 1, 2, and 3, and look at them. Data 1, no index, the subject ID, and the people. Data 2 are some different people, names starting with B. And data 3 is the match, or the correspondence between the subject ID and the test ID that they have to take. And test IDs are some numbers. Okay, imagine that we want to look at all of the people, from the first group and the second group, and combine them somehow for the further analysis. Well, we can concatenate these 2 data frames, and this is what we have. The by default concatenation goes vertically, and we have a list of all the people from the first group and then to the second group. Luckily, the names of the variables are the same, and therefore we have this full merge where the 2 tables are just put one after another. Look at the index that is here. It's also just concatenated together. Now we can do the same thing but along a different axis. So if axis equals 1 in the arguments of the concat function, then what we have is that we have tables put side by side in the wide manner rather than tall in a previous example. Now we can do an actual merge. So instead of concatenation, we want to merge, in this case, data all rows and data 3. So data all rows, that's this data set, and want to merge it with the third data set. So this is a list of all of the people, and we wanted to merge the test IDs that they would have to take according to the subjects that they've taken. And this is how we do it. We take all of the people and we merge them with the test IDs on subject ID. So we want to use subject ID as the linkage between the 2 tables. And you can see that we have all of the people in the resulting table. And for each of the subjects, we've added the corresponding test ID. if we look at the test ID, subject 1 has 51 and say subject 4 is 61, and that's what we have here. Subject 1 is 51, subject 4 is 61, and here 2 people are taking subject 4, and both of them are assigned a test ID of 61 as they should have. We can add additional parameters, and imagine that I want to find out the people who are taking the same subjects from the 2 different lists. So I'm going to merge on subject ID variable as well, but now I want the inner merge. And the inner here means that we will take only the people who appear on both data 1 and data 2 according to the linkage over the subject ID. And there are 2 people like that, Alice and Billy, and Young and Brian, as you can see. The opposite of that is the outer merge. The outer merge leaves all of the people who are in either of the tables. And you can see that the people who have the same subject ID, they are merged into the same rows, but the people in the second table who don't have the subject ID, which doesn't have any people in the second table, just is initialized with not a number. And the same thing goes for the other half, for the subject IDs where only the people from the second table exist. And besides inner and outer merge, there's a left and a right merge, which would take the subset of, allowing missing data from first or the second table. So that concludes a very short overview of Pandas. We will use the features of this library, and every time we want to do something, it's a good idea to go and find the relevant methods in the reference manual. There's a wonderful CompEcon lecture on Pandas, actually on 2 of them. And in addition, CompEcon has this year started a section on data science, which has a very, very good tutorial on Pandas that goes more into detail than what I've done here. And you're very welcome to consult this tutorial, this material as well. That's it for this video.